Welcome to all. See, yesterday I could not upload the class because of some power problem here. So one class missed. Otherwise, daily I will upload the class. See. Question 75. Remember, something important is there. I will let you know little later. I will first read the question. Find the value of P. See here, of P. I have not done P here. You see, I wrote everything. Forgot to write P. Okay. Weight equal to, I forgot now what weight I wrote here, see. Okay, 600 Newton. I think 600 Newton most probably. Okay, then, see here. Horizontal, P. Find the value of P for which the block B is on the verge of moving to right side. Or the question can also be asked, instead of find the value of P when the block B is on the verge of moving to right side, question can also be asked, find the minimum value of P to start motion or motion of block B to right side, or find the least value of P for which block B will start moving to right side. This all over so many times. Okay. Coefficient of friction for contact surfaces of the two blocks. See, there's a contact surface here. This is a case of a block A resting on block B. Surface of two blocks, that is A and B, understood, is 0.2. Here mu is 0.2. And for the contact surface of block B with the bottom, see, with the bottom surface, or you can tell a ground level at the bottom, see, is 0.35. Or you can do one thing to understand correctly. See, I write here only now. See, later. Here, mu equal to 0.2. This surface, mu equal to 0.35. Okay. Now, the question can be given by words also. Difficult to give words. See, for the block A cable is attached. It is fixed here. It is very important. If the cable is not there, then the block A, you don't have to consider, it will add up this weight. See, for block B, weight will become 800 newtons. That all I will explain later. Okay, now, see, there is very important for the block A, some connection is there here. It is connected by a cable. Now, first time in the class, you are seeing a question where one block is resting over other block. This is question number 75. See here, cable is horizontal, force also is horizontal. Now, today I will complete this question. Lot of concepts are there to understand. Today's class almost concept based. Very important concept. See, next class, this is 75, 76, 77, 78, all these three I will solve. And there, see, 76 is same as, I may not change the weight. I may put same 200 and I will not change any other values. Arrangement I will change. But you should take all independent question. Okay. 76 is cable is still horizontal, but the force P is inclined. See here, P and cable both are horizontal. Here, cable is horizontal only, P is inclined. Question 77, next class. Force is horizontal, but cable is inclined. What angle I will tell you in the next class. Question 78. Force is inclined, cable also inclined. Usually, it is a very simple question. If it is asked in examination, they may not give this way. They may give either this way or this way. They may give either inclined force here and horizontal cable, or inclined cable, horizontal force. Or the person can give little more marks and give both inclined. Now, you can take it as an advice from me. If you really think I got capacity to teach and you are really learning from me, you take it as advice. Or if you think, yeah, I know everything, I also know. If that feeling is there, I will tell it as a warning. Because something goes wrong later, it is a warning. I will tell, suppose If it is an offline class, I will tell, I told you earlier, why you did not listen properly? Sir, I thought I can do. You thought you can do, but you cannot do it. So, my simple language, polite way, it is advice. And harsh language, it is a warning that, see, all these questions. And also, I will remove this one now. I will tell now only. See, those you should make a note. And also, more questions coming up later. See, I will take up a case of a inclined plane. I will place one block here. Place another block here, over that one. Put a cable. Some force either prevent from sliding or try to move up or hold it in position. These questions. Again here, I may put inclined cable. Okay. These questions. And also in friction, especially for those who are studying for examination, subject is engineering mechanics. You can see question papers. In the friction, these connected blocks or single block on inclined plane, they give occasionally question. And ladder friction also is important. But you can see the question paper, the most important question which comes in examination for friction is wedge friction. Because later work is there, wedge friction. How is wedge friction means? See, some block will be given for you, this way resting, and then, okay, this way, okay. This way, some wedge will be here, a force will be asked here, some surface is here, okay, this weight will be given for you. Except, don't worry too much now. What force required to lift the wedge like that? So, wedge friction, make a note, we will cover it. Wedge friction, which is very important from examination point of view. When you go to wedge friction, all there, what I am going to tell today's class concept is very, very important. See, very, very important concept I will tell today. Will explain thoroughly today so that you understand. First principle point of view I will explain. Then I will tell some practical example for that one to understand. Then even a crude method also I will tell, because so many people, they get confusion when they come to friction between these two. How to take friction for A, how to take friction for B, or here also, see, I told this way. Or in wedge friction, how to take friction for wedge, how to take friction for block. Confusion. If you make a mistake there, question is gone. Therefore, I will explain everything first by real concept. Then, I will give some practical example also to understand. Lastly, I will even tell a crude method. See, actually crude method is not good, but crude method is useful from examination point of view. When I teach structural engineering for professionals, structural engineering, there I avoid crude methods. But one thing, I give practical example to understand. When some people don't understand concept, I will tell some money matter or running race. So many things I will tell. Then they will understand. Then I will tell, this is for understanding. Don't tell later money matter, etc. or eating. Sometime eating also will come. Don't tell those things. Understand the principle. So I will tell here only, see, today I will explain thoroughly, and later when you go to question number 76, 77, 78 for this same I told just now, and also for the question of inclined plane, one block placed over other block, and also when you go to wedge friction, at that time only brief explanation I will tell at that time. If not clear, it is your problem. You have not gone through the principal class earlier. I will advise them, go back to the class where I started one block above other one. Understand what all I tell, then come back here. You will very easily solve. So, therefore, this powerful concept is there. Now, before I go to this question, To understand that concept, I will take an example here. See, example, and make a note here. See, I will remove all this now. See, very important concept. That's why today only one question. This question will take not more than 2 minutes. Okay. Example, and make a note here. This example is already over in the beginning of friction chapter. But you make a note. To understand thoroughly, make a note. Example question, no question number. It is for purpose of understanding the concept of, some people call, friction for two quantities, for the two blocks or etc., two parts, two body, when they are in contact, both has got frictional force. It comes in when something is placed over other one, or wedge friction later you require it. In such cases, to understand the concept, take example. You take a mini example. Consider a block weighing 500 Newton. See, placed on a rough horizontal surface with the coefficient of friction 0.4. Now, find a force P is applied to the block. Find the value of P when the block is on the verge of moving to right side, is the question. See, don't by heart right side. It can be left side. Here, right side. See, first I will solve the question. See, I will first solve this question. Actually, there is no question number here. It is an example you require for understanding something. See, I will do one thing now. Solution I will make. Solution. How to start solution? See, consider the equilibrium of the block. See, its weight is acting 500 Newton down. You are finding a force P here. Force P you have to find out. Which, when the block is on the verge of moving, see, very important, when the block is on the verge of moving to right side, then if you remember, so many stories there, when it is on the verge of moving, limiting friction will come. Okay, that all over. So we know that limiting frictional force, FF limit equal to mu into normal reaction. You write, let R be normal reaction and FF limit be reaction due to limiting friction. Okay, start this statement. Don't see that side. See this side. Let R be normal reaction. See here. I'll put red color. R be normal reaction, moving right side, no? Therefore, I have to slightly shift it. Y means don't bother, because I know the concept. Okay. Some will tell, sir, we also know it. Good. If you know it, by this time, see, you told earlier, see, long back I told, therefore, we also know it. Very good. I'm happy. Okay. That R be normal reaction and FF limit be frictional force for the block B. See, this is your block. This is only one block here. See, this is trying to move right side. So, friction is left side. Very, very important. This is FF limit for this block equal to, you know it, mu times normal reaction. You write here, somewhere you write here, that FF limit is mu times the normal reaction and mu is 0.4, therefore equal to 0.4 into normal reaction R. Okay, this much you write. Now, this is, some will tell, sir, this we know it. You know it correctly, but you are not knowing perfect meaning. This R, see here, this R and this FF limit of 0.4 R, R means not this R, this normal reaction R and limiting frictional force of 0.4 times this capital R, these two are what? They are the reaction. They are the reactions. Reactions on the block. Very, very important. Reactions on the block from the contact surface. From the contact surface. Now, see. So, I wrote here, see. Let R, I am slowly doing it. Let R be normal reaction and FF limit be reaction due to, see, we write limiting frictional force. Remember, even if you write limiting frictional force, it is a reaction. Why? When it moves to right side, to balance it, It's a reaction from the surface here. See, when it moves this way, friction comes from the surface here, this way. That is acting on the block. So that is reaction. R is the normal reaction. FF limit is actually in the beginning of the subject. I used to write reaction. Then I stopped it. I used to write frictional force. Reaction due to limiting friction on the block. I will not tell again and again. Already told, it is on the block from the surface on which the block is placed. Okay, now this much over. Now you solve it. Now this is in equilibrium. Okay, solve. See. Solving, see, sigma as usual. I don't have to waste time now. See, your x, y, y is usual. This time no confusion because horizontal plane. See, this you take xx, ink problem. Okay. I have put too much ink. Okay, no what to do, nothing to worry. These things happen. See, these things all I am not bothered. See, as usual, remember, this is your xx, this is your yy. I don't have to explain. So, what you make? Sigma fy0, take this way positive, upward positive. You get plus r. Okay, I use red color. Okay, I use red color. Plus r minus 500 equal to 0. Therefore, your R equal to plus 500 Newton. Plus 500 Newton. Okay. And make sigma Fx0, take right side positive. What you get? Plus P, see, plus P minus 0.4 times R, I am using red color for unknown, equal to 0, substitute that R equal to 500 Newton, you get plus P minus 0.4 into 500 equal to 0, you will get P equal to plus 200 Newton. And one more thing you do here, if P is 200 Newton, see here, your friction, and one more thing you note here, the frictional force, therefore, actually you require today. So far you never require. Why? You got the answer, question is over. But here, therefore, that frictional force, FF limit, I will tell you should write. FF limit, what you calculated, is equal to, how much? 0.4 R. 0.4 R is equal to P only. If you calculate, equal to 0.4 into 200. Sorry, not R is 500. Okay. R is 500 equal to 200 Newton. Red color I'll put. FF limit equal to plus is not required. Okay, 200 Newton. This you got. Some will tell this person has no other work to do. He is wasting time. I am not wasting time. I am giving you beautiful concept required. Without that concept, you cannot solve this question. You cannot solve any question when one block is placed over other one and wedge friction. Okay. Now, do one thing. Write correctly answer. See. Therefore, now if you consider the block once again, block again with the numerical value, then see, this weight is, how much weight? 500 Newton acting down, this everybody knows, acting down, and to move it to right side, you require, I will put a black color here, P. Now P is not important. You had apply a force P of 200 Newton when the block is on the work job moving. Then this contact surface, see, this contact surface, from the surface to this block, there is a normal reaction R equal to 500 Newton, and also from the contact surface to the block, there is a frictional force here. See, this way, frictional force limit of how much? Once again, 200 Newton. 200 Newton. Now, very, very important. See, I am slowly telling it. Some will tell he is wasting time. Okay, I can solve very fast. Don't think I cannot solve. These questions solve without explaining. So many questions I can solve in few seconds also. Maybe few seconds means not 1 second, 2 seconds. I won't lie that way. 10, 15 seconds like that. So now, see, read the statement once again. Let R be normal reaction. FF limit is the frictional force. This also reaction on the block from the surface. Therefore, very, very important. See, these two are very, very important. These two are reactions on the block from the surface. Okay. Now what I am telling, correctly understand. Now consider, see, now do one thing. Consider what forces the surface gets. See, now consider or find, now get what forces the surface will get. This is the most important part of today's class. Most important, not moment of inertia. Most important. Sketch the surface. I am sketching surface now. See, 1 minute. Before going further, I will tell you. Somebody, see, there is a wall here. I will push the wall to right side by 100 kg force. Wall will give me a reaction of 100 kg force. So if the wall gives a reaction of 100 kg force this way, means I am pushing the wall 100 kg like this. Or one more thing, see here. I will take my hand. This weight is, see, 500 Newton, okay, 50 kgs. I will place on my hand. See, this weight of 500 Newton is resting on my hand. It will press my hand down, correct? Therefore, see, for equilibrium, I will lift it by 500 kg. So, for the block, weight is 500. From my hand, I am applying 500 kg up. If I am applying 500 kg up, it means I am getting 500 kg down. See, action and reactions are equal in magnitude and opposite in direction. So this is a very powerful concept. Later when you go to strength of materials, when you place a beam on a column or slab on a beam or beam on a column or one member over other member, that mutual reaction part I will thoroughly explain there. For one member it is action, other member it is reaction. One of them is called supported member, other is called supporting member. Force from the supported member, from the supporting member to supported member, we get reaction. See, from the here there is no member here, surface here. From the supporting surface to the supporting member, see, this is supporting member. This is supported member. This is supporting member, surface. So from the supporting member to the supported member, you get reaction. Reverse is force transferred from supported member to supporting member. Or, I will tell once again, see, for example, imagine there is a beam here, a column. Imagine some load will come. From the beam to the column, some load will come, say 2 ton load. So if a load of 2 ton comes to the column will lift the beam up by 2 ton. So that up 2 ton is the reaction for the beam from the column. So if the reaction on the beam from the column is 2 ton up, means the beam is pressing the column down by 2 ton. Or somebody gave me 100 rupees today. When I am going somewhere, see, someone came to me and told me, see, I'll tell you. See, he will tell me, sir, thank you. No charity. So he will give me, see, sir, 100 rupees. 100 rupees note. Sir, thank you, sir. So settled, sir. Okay. If he gives me 100 rupees today, it means earlier day I have given him 100 rupees. See, if he gives 100 rupees to me, reaction means action. Maybe yesterday or 2 days earlier or 3 days earlier, maybe he asked me, sir, little money required. I don't have cash. Can you please help me 100 rupees? Okay, I will tell. See, not today. Some other day, maybe I given him 100 rupees. So today he gave 100 rupees. So when he gives me 100 rupees here, received, what someone will think? See, that person reacted by giving 100 rupees. It is reacted. So he gave 100 rupees to me. If I took it, okay, thank you. And then actually he should tell thanks. I should not tell thanks. But present day is not that way. Sometime if you get your money back, you tell thanks. Okay, anything. He will tell you, sir, 100 rupees, returned. Returned 100 rupees. Okay. Somebody will be knowing, oh, maybe this lecturer yesterday or previous day or some other day has given him 100 rupees. Therefore, if for the block reaction of, see, now you should write everything. For the block from the surface, see, these are the reactions for the block from the surface. If an up reaction of 500 Newton is there, that means for the surface here, there's a downward load acting of 500 Newton, which is equal to this R. See, reaction 500 means reverse action 500. And if this surface, see, this is the friction for the block from the surface. From the surface to the block, if a friction of 200 is acting, means the surface is getting a force like this of how much? 200 Newton, equal to this one. Or see correctly, it is a common sense. When I move, see, when I move like this, see, this way, for my upper hand, friction comes this way. If for upper hand, if friction comes this way, means for the lower hand, the force coming is this way. See, rubbing. This is the rubbing force. This is the reaction due to rubbing. See, this will rub this one. See, this will press this down by 100. Reaction on this, see, this will, the upper block will press the surface down by 100. That's why surface gives you up reaction on that one for equilibrium. And upper blocks rubs the surface, see, this way. So due to friction for the lower block, upper block is rubbing, see, rubbing. So this is experiencing a force like this. That's why it is giving friction force like this. I think this much is sufficient. I told you, if I get 100 rupees today, means some day earlier I have given 100 rupees. See, sometime in the school, complaint will go to teacher, usually miss. Some will tell, miss, so and so hit me. He hit me. Miss will call him. Why? Because that day he hit me. See, I hit him today because yesterday while going from the school, he hit me and ran. So I take revenge. Same way, see, this, be careful. If the reaction is up 500, for the block down 500, for the block if friction is left 500, surface is getting right 500. This is the important concept you have to remember. Okay, now sufficient. I will come to this question now and solve. Already too much time is taken for explanation, but go through thoroughly. I know. You show me one place where this much explanation is given. Okay, tell me, show me. Where so much example given. Okay, now, when I come here, I will tell one more practical example and also tell you crude method now. Okay, I will rub this one everything. So, what all I told today, you should not forget. Remember for the upcoming problems. Okay, I'll rub and solve this question now. I will solve now. See, let T be tension in the cable. Do one thing. You write this sketch once again. Good for health. See, don't write in the original question. See, always, if I enter something in the question to space problem here, you should never enter it in the original question. What will happen is, problem will, I always tell, what question given, don't touch it. So therefore, this sketch, see, this sketch, you write once again here to understand. Next time not required because you already know it. See, tension means pulling this way. This you already know it. But still to understand, right, let T be tension in the cable. Then consider equilibrium of block A. Again remember, block A, because your unknown is for block B. You should start from always that block where unknown, where in the question what unknown is there, that you should do last. See, this I told. Or, see here, if I take block A, tension, reaction, two unknowns. Friction is in terms of reaction. If I take block B, then P, this reaction and this vertical force acting, reverse of this one, contact surface forces. So more unknowns here. Therefore, first consider equilibrium of block A. See here, block A, weight acting down of 200 Newton. Show it here. Then tension T, see, this tension, because which is acting on the block A, mark tension T. Okay, touch it. Some will tell, sorry, it is actually outside. Okay, touch it. What is there? Okay. Then, this block is resting on this block. This will press this block down. So, there will be a normal reaction here. See, R, normal reaction R for block A from block B. RAB. See here, normal, see here, first suffix is on what? Second suffix is from where? You make a note here. First suffix is from what? For what? Second suffix is from where? So, normal reaction R for the block A, normal reaction, see, on the block A, B section, this is, see, these two are, see, for these two, this is common. RAB, normal reaction on block A from block B, and FF limit, sorry, FF limit B, limiting frictional force on block A from block B, on block A from block B. See, FF limit on A from B equal to, this is same, see, this mu is how much here? 0.2, that I won't waste time, you should write here. This is 0.2 times normal reaction, 0.2 times RAB, mu RAB, this mu, okay. Now, RAB is simple, see, this is pressing down, reaction up, this is the reaction for this block. Frictional force direction, this is the most important. This is what is the important. See here. For the block B, see, block B is later going right side. So when this block B is going right side, friction for block B is left side. See, it is left side. If friction for block B is left side, friction for block A is right side. Very important. It is same as P. So your frictional force for block A at the bottom contact surface is like this. See, right side, not left side, because when the block B goes that way, it will rub the block A. This see, block B, when it moves that side, this block, it will rub like this. See, rub. So, that is this way. I will explain more once again later. Okay. Point to RAB. This I won't explain again. This I will explain once again. See, right here. This I will explain again and again. Or once again. Okay. Now, write this much. Now, as usual, don't waste time on XX, YY. See, this is XX, this is YY. Later here also, this is XX, this is YY. Don't waste time here. Okay, start. Sigma FY0 plus RAB minus 200 equal to 0. RAB equal to plus 200. Then minus T plus 0.2 RAB equal to 0. So substitute RAB equal to 200 Newton, your T will come 40 Newton. Actually, T is not required for next part. We want only RAB. That is carried forward. T I am getting because some examination, they will ask the question for you. What is also fine, what is the tension in the cable? Okay, over. Now consider equilibrium of block B. See here, block B. Very careful. See, block, you should write here. First consider block B resting on the bottom horizontal surface or ground. You can tell ground surface. It's not a ground actually. You see right here. See, first you consider the contact of, you should write here. Those who want to seriously understand everything, what all I dictate right here. First you consider B resting on what? Resting on the bottom horizontal surface. So, from the bottom horizontal surface, this will press down, normal reaction R, and this is on the verge of moving right side, so friction is left side. This is as usual, see, this is as usual. As usual, that is up to today, what we have done so far, every class, see, this is moving right side, friction is left side here, and this will press down, reaction is up. See, suffix is not there because this is RB, there is no surface, there is no block here. So simply R. Or you can write, you can't, if you are that much eager, you write some surface C, RBC, not required. So, see here, for the block B, I am telling block B, up, normal reaction, suffix not required, and frictional force, see, no suffix here, 0.35, why 0.35? See, this contact surface mu is 0.35. That you have to write. Okay, now, what about the top? You write all this, you write here. Now, this much statement you write here on block B from the contact surface of the, see, normal reaction and frictional reaction. Actually, remember, this is frictional reaction. Remember, even if you write limiting frictional reaction it is. Reaction on block B from the contact surface. This is usual. Now, what I dictate, you write. See, what all I dictate, you write here. Somewhere outside. Now, the most important is, what about the top surface? See, top surface, this top surface, see here, I will put a green color here now. This top surface, I use a green color, is nothing but, see, that top surface there is nothing but this bottom surface. See here, green color. I will make dark here, see. These are same. The top surface of block B is bottom of A. Now see correctly. For the block A from block B, there is normal reaction up. See, for this block, there's an upward reaction. Means from block B to block A, there is a force acting in the downward direction. Opposite. See, contact surface, these two are, see, These two are what? Not interchange, direction change. See, for the block I forgot to put A here. Okay, block A. For the block A, if reaction is up, see, question mark, down. I'll remove the question mark now. This is the reaction, normal reaction. See, actually it is R on B from A. This is R on A from B. See here, R on A from B. This is R on B from A. RBA is equal to RAB. Why? Action and see how much is the reaction, that much action. See, if this is giving up reaction, means this is getting down force. See, for the upward member, this way reaction. For downward member, this way force. Equal to, you know the answer. Write the answer. Whatever you got, write the answer. You already know it. I don't know why. What happened to the pen? The cap is not coming out. See, again due to friction. See, I pressed too much. Heavy friction is there now. Up. See, this is friction. Okay. Equal to, you know the answer. Where I write? See, equal to, where is it? 200 Newton. 200 Newton. Okay. Now, what about the friction here? See, this friction. For block A from block B, your block B is rubbing the block A. See, your block B is see, this your block B is rubbing block A like this. Therefore, see here, if it rubs it like this, this will rub it in the opposite direction. See, or FF limit for A from B is, whatever is the direction here, reverse here. This is FF limit on block B from block A. FF limit from block B from block A equal to FF limit on block A from B equal to, see here, FF limit on block A from block B is 0.2 RAB. Right here. Space problem is there. I write here equal to, black I will write 0.2 times RAB. RAB is 0.2 times how much RAB? 200 equal to 40 Newton. 1 minute. If the camera is not visible, I slightly turn the camera. I think camera is not visible, I think. Yes. Not fully visible. I slightly turn the camera. Okay, that side is not required now. Okay, now okay, I think. Okay, now okay. In your next 3 questions or further more questions also, I will tell every time this one, but this much I can't explain. So remember, for block A from block B, up means from block, see, for block A from block B, here this contact, see, block A, see here, block A from block B, up means for block B from block A, down. Whatever answer here, same answer here. And from block B to block A, this way friction means for block B from block A, reverse friction. This is very important. Now, I will first solve it and then I will explain some other way also to understand correctly. Some other way, easy method is there. Okay, 1 minute. This all I will remove now. None of them required. Okay, none of them required now. Okay, now it's not required. Okay, I'll start now. See. Okay, start. Continue. This one. Continue here. Now nothing is there. See. Sigma Fy0, take upward positive. What you get? Plus R minus 600 minus 200 equal to 0. or your R equal to plus 800. See, 1 minute. You can check the answer because this weight is 200, this weight is 600. Both the weight will come to bottom. See, from here, the weight will be transferred to this one. Finally here, both the weights will be added up. Okay, then sigma fx0, take right side positive, plus p, see, plus p, then minus 40, see, this one 40. That is ff limit for b from a minus 40 minus 0.35 times this r. That is which r? R at the bottom, top R is the top side. Both values are known for you now. Now, substitute that R equal to, just now we got R equal to 800 Newton plus 800 Newton. You will get plus P, actually I should not tell now, plus P minus 40 minus 0.35 into 800 equal to 0. Therefore, this all over already. Therefore, P equal to the least force P required in Newton is, where's the calculator? I don't know where I kept the calculator. Oh, I did not bring the calculator here. I have to pause the recording. So far I thought without calculator. Okay. I can do still without calculator, but why not take chances? Okay. Answer will come plus 320 Newton. Okay, now if I am writing examination, I will not solve this way. See what I will do. See now. 200 into quantite 0.2, 200 into 0.2 is 40. Okay, 40 I remember. 200 plus 600, 800. 800 into 0.35 is 280. 280 is the friction here. That friction will once again come this way, plus 40, 320 Newton over. If I am writing examination, but I am not writing examination, don't worry. I will not be a competitor to you. Don't worry about it. Over. Solution is over. Now, I will tell you one easy method, or first of all, one easy concept. See, when this block is going right side, see, when this block is going right side, relatively, this will look like going left side. See, you make a note here. See, you make a note. This is a crude method. See, not crude. When this block is going right side, see, then this is going right side, this block will look like going left side. See here, it is a relative motion. See correctly. See, this is not friction. See, when this hand is going that way, that hand will come this way. Or when you are going in the road, high speed, if you look outside, as your vehicle, car or bus, looks like going forward, side trees etc. looks like moving backwards. See, as you drive, suddenly you look this way, you see all the trees, buildings all will move. See, when you are going this way, that will move this way. Friction is always opposite. So, see now if you separate here, see, separate here. See, this contact, no problem. Right side, friction left side. Okay. Here, going right side, friction left side. Going left side, friction right side. See here. See, this is another easy method. Relative motion. See, this way. Like when you drive a vehicle, see, your vehicle, bus or car, looks like going forward. Side buildings, windows you see, all looking backward. See here now. This, see, first important here, this is our main purpose is, this is the block. This is to go right side. Relatively, this looks like going left side, see. So, now see here, this goes right side, friction is left side. This goes left side, actually it won't go left side, friction is right side. See, or, see now, one more thing. see here, if I hold this way and see, if I move this one fast this side, see, if I move fast this one, see, jerk for this one, see, it is coming this side. That is easiest way to understand. Or there is one more crude method is there. Okay, remember it. You require it later. When I solve next question, I will tell the correct concept and this relative concept and also crude method. Crude method is you put this sketch. Okay, then do not do any, put this sketch. This is okay. This RAB okay. Friction keep pending. Direction pending. Don't put direction here. Okay, then go to that sketch. Leave space here for solving. Go to that sketch. This is our main, see here. This is going right side. Friction left side, friction left side. Because both the contact surface, when it goes this way, friction comes this way. Now do one thing. By seeing this left side here, put right side here. Crude method. See, at the contact surface, for the first block, don't write anything. Other things you write. Friction keep pending. Leave space for this calculation. Or write both the sketches simultaneously, then write for block 1 and block 2. See, both sketches, leave some space. Okay, then complete this one. See, R is no, this is no problem. See, going right side, friction left. Come back here. Oh, for this block from that, if it is left, for this block from here, it is right. And this is okay. That block will press it down, reaction up. So that block will press it down. So react, or if reaction is up, action is down. This I will tell in the next questions also. Every time I solve a question on this type, question number 75, 76, 77, 78 also, briefly I will tell. Even when I solve a question of this type, see, I told you. This is exam question, very important question. Here also I will tell, and when I go to wedge friction also, I will tell correct principle, that relative motion, bus going forward, other way moving backwards, or see here, if I move it this way, then this one looks like, see, both moving this way, no friction. This is not friction. This I will tell, but not this much. Briefly I will tell, and I will tell, I already advised you, and also for those who are really getting benefit from me, and those who treat me as their real teacher, advice, polite advice. Those who think little arrogant, nobody should be arrogant with me, or they think I also know it, or this person knows little better than me. See that feeling. So this person knows little better than me. That feeling, it should never come to you. You should think this person knows much above me or more than me. You surrender, then only you learn. By this time you can make out. If I tell further, it becomes boosting only, leave it. But it is a fact. So, therefore, those people who think they are also equally good, if they don't listen properly, it's a warning. I told you on that day you did it or followed it, now pay the penalty. Sir, I made a mistake. Yes, your problem. Why? Sir, I thought I can do it, but last moment got confused. It happened. In my offline class, nobody will do that way. Everybody who come to me, to my class, each and everybody, they will tell me, sir, we know nothing. What is your level? Sir, negative they will tell, not even 0. I will tell, don't worry, I am there to lift you, but don't expect me to lift to my level. Sir, 10% of your is sufficient, they will tell. Okay, that I can do. I will tell you, 10 or 15, 20% of my, I don't want to sell further. If you come to that level, it is more sufficient. Remaining 80%, you should start developing. How? Not by practicing, not by solving problem, by seeing that subject goes inside the blood. See, inside the blood it should go. It has gone for me, what to do? Okay. If I tell further, they will tell story writing. See, such things are required. People should know where they stand. Okay, now 75 over. Next class 76, 77, 78. One more class 79, 80. Then I'll go to wedge friction. Once I finish wedge friction, I'll go to ladder friction. Once ladder friction is over, friction is over, we will tell goodbye to engineering mechanics and enter the most fascinating and the most important and number one for structural knowledge, that is strength of materials. I hope at least then more and more people will come. Actually, again, I told you, you see that my class is shared and information is given for more and more people. You are not doing it. I can see by the views. I know, if not today, tomorrow. If not tomorrow, next year. A day will come, I know it, when my class will be recognized. Views will start coming. When I upload a class, within no time, views should cross the 100,000 views. But now it is not happening. Counted views only, few. Why? People are not so much interested in knowledge all. Or so many people, they recently they join, they tell, sir, we are not knowing. See, we are not knowing. So, to support my cause, you see that all these things are shared and reaches maximum people. Comment section, you write something. See, your comments also counts. When you put comments, someone will see the comment. If you see a good comment, he will be interested. But I am not telling you, you praise me and put comment. Whatever you comes to your mind, you write. Hope that you will put a good comment only, because I know I don't deserve bad comments or telling useless class, nobody can understand. I don't think I deserve it, or no one will put that way. Very few, 1 in lakh will be there. One person has commented long back. He does not know how to define centroid. Let him come in front of me. I will teach him a good lesson. But I first thought of making a video for that one. Then I decided, if someone will shout and that innocent person foolishly comment something, for my dignity, why should I respond? Keep quiet. See, sometimes if disturbance comes, keep quiet. People know my capacity. Okay, too much of talking is there now. Okay. We will meet in the next class. Thank you.